asked on the Discord server. I don't think I asked my question clearly. Can we do colored boxes instead of writing the player's initials? No, you got to put the initials in the box. That's according to the 1968 dots game convention ruling. So, or you can do it, but you can color code it too and make it look slick. But, you know, just grab the first character of the player's name. How do you go about replacing one component with another? For example, I would like to replace the user's name input JText field with a JLabel displaying their name. Well, you got a few options. So if you want to actually replace the component, you can create a JText field and create a JLabel, and you can use their set visible properties. Make your text field visible and your label invisible, and then when you want to swap them, just make the text field invisible and the label visible, and that'll appear to replace one with another. You also have the option of disabling your text field, right? Just set the enabled property to false, and then it will still appear, but it will be grayed out and it won't be editable, and so you can use that as a display for the user's name if you want. But the most precise control, just play with the visibility, and that lets you make them appear or disappear. And that's certainly preferable to actually creating and destroying the objects at runtime. Just change their visibility. You are welcome. All right, so we're going to do an open lab tomorrow, as we've been doing on Thursdays. So I think people are still working on finishing up PA4. So we'll do an open lab tomorrow. If you have questions, want to work on it or whatever, come on in, and we can play around with it in screen share and such. Other questions on PA4? I definitely have the nagging feeling I'm forgetting something. I don't know what. Maybe I forgot to like record the lecture or turn on audio or share my screen or put my head on or something. But let me know if anything's missing. Speaking of destroying objects, does Java have any convention of immutable objects that cannot be destroyed? Like I used to do flash-flex programming. If you created components through XML, you couldn't destroy them. Not that I'm aware of, but I don't think we have a notion of destroying objects in Java as much as we have, you know, just sort of not referencing them anymore, and then they get garbage collected. And there are some deprecated destroy methods for different things like threads and such that that we don't use much anymore. But yeah, so I don't think so. Welcome. All right. Well, let's hop into Java. Let's play with server sockets. So remember our setup here. We're going to have some kind of server, and we're going to have some kind of client or clients. And the server is going to be identified by an IP address, and the particular port that we're going to connect to a socket is going to be identified by a port number. And so let's write some code to do the first piece of this and simply create a server socket and make connections to it from a client side. And so a couple of tools that I'll mention along the way. The first one is netstat. And netstat is really useful to see what's going on connection-wise on your system. And so if you just say netstat, you get a list of all these different connections in different states. And there's different protocols. All of these down at the bottom are Unix connections, but usually up at the top, I think these are alphabetized by column 1. Up at the top we have these TCP connections. So this is the protocol, this is the receive and send queue. Here's the local address. Nitro is the brand and name of my laptop. So this is an address, colon, a port number. And then the foreign address, so, you know, connections are made from one machine to another. So all of these machines originate, or, you know, the local end is on my machine. The remote end is at various different places. Pulsar-public-RNO, I have no idea what that is. Nor do I know what Rover Web Public is. But 192, 168, those are my local address. So, you know, there's probably a connection to my printer if I printed recently, and so on and so forth. EnigPair.com, that's my web hosting service. And so I have connections to that, and so on and so forth. And each of these connections is in a different state. Established means the connection is ongoing, right? Both ends are active. Most of these, close wait, last acknowledgement, these are where the system is shutting down. Time wait would be another one. Yeah, you've got to love unknown connections. 433 is an HTTPS. HTTPS works on a number of different ports, 8081 and I think 443 and so on. And so we can netstat and, you know, just pull out the TCP ones. If we do -A-N, this will show us active connections, and it will replace the translated information with raw address information. And so here's you know, just IP addresses and port numbers. And so we could correlate those back. So the HTTP was port 443. I'm curious what that is. Sounds like one of mine. Last entry. Okay. All right. Okay. Yeah, it's a long scroll. So netstat's useful when you're trying to do socketed connections from your machine. You can use this sometimes to figure out what's going on. Is there something listening for a connection? Is there you know, a connection made, and so on and so forth. I'm really curious about the 1716. So let's see what happens on the Java side. So I'm going to do this in Eclipse. I'm not going to use a GUI or anything, but Eclipse will do our imports for us, and so on and so forth. So let's go ahead and make a project. And I will call this JP. And let's go ahead and make a main class. So new class, I'll just call it server demo. And I should have told it to make me a public static void main, but I forgot. Just to prove we can. All right, so we're going to use a few classes here. The main one we're going to use is a server socket. So server socket comes from java.net, and basically we can construct a server socket by specifying a port number. And this will be a socket sitting on whatever machine we run this code on, which we're assuming we're running this on the server right now. It will have the IP address of that machine, but the port number will come from what we give the constructor. And if we don't construct with a particular port number, it'll be what's called an unbound socket. We would need to go in later and actually bind it to a particular port. We're just going to do the most straightforward thing. We're going to construct it with a port number. And so let's declare a server socket called SS. And we'll make a new server socket. Someone give me your favorite port number above 1023. But not one that's in use. Well, that's probably not in use. But I'm not going to use that because someone will use it. So we'll modulate that. Okay, we'll do 7777. Alright, that's a nice harmless number. You can use pretty much any number you want. You got to be above 1023 if you're not root. You don't want to use, 22 because that's your SSH daemon and so on. But if you're not running services on those, you can reuse, those numbers for anything you want. I could make a port 80, right? But anybody who happened to ping my router with a web browser and look for web pages would now be talking to my Java code. Probably not a problem, but might be kind of weird. Yeah, or 8080. If you want to mess with someone. Alright, so we're going to make a new server socket. And we need to do some imports. So I'll just let Eclipse do this for me. We'll import server socket. And then the construction has to go in a try-catch block. So I'll take the lazy path and let Eclipse do that for me. And we'll print out an error message in a stack trace and we'll return. Otherwise, we've got a server socket now. Alright, now if I run this, not a whole lot happens. It constructs the socket, it says server socket created, yay, and then it just exits. How did you get it to import? Oh, so hover over the underlined line and then wait a second and it should bring up a pop-up. If it doesn't, sometimes hovering over this will work. Sometimes putting your mouse here and hitting Alt-Enter will bring up options, but best bet for me usually is just put the mouse over there and then wait a few seconds and then come down to whichever one you want. In this case, just import. And yeah, so the try catch also, hover over it and it says, can throw an exception, either add throws declaration or add a try catch. And I selected add the try catch for me. We'll do that a few more times. Alright, so it's warning me now, that I'm not using, I'm not closing the server socket, right? So I'm not worried about that. Alright, we've got a server socket. What do we do with it? It's basically creating this thing out here now on my machine, and theoretically a client could try to connect to it. But before we can connect to the server socket needs to say, I'm ready to accept connections. So we have to use one method from the server socket, which is accept. And so accept does two things. One, it listens for connection requests, and then it accepts a connection request that's made. So if we run the accept method on the server socket, it will hang out and wait for somebody to try to connect to it. So let's go ahead and do that. So we'll say we're waiting for a connection, and let's do serversocket.accept. Now it's going to want to throw this inside a try-catch block. So again, I'll hover, I'll come down to surround with try-catch. The bottom of my window always pops up and occludes it, so then I just come up a little and I scroll wheel down to expose it. Or just move away and come back, and the second time it seems to work fine. These are just things you learn about Eclipse that you don't even think about until you try to explain it to someone. All right. So we'll accept the connection, and I'll do the same thing in here. We'll just say something went wrong while accepting a connection, and we'll get out of here. Otherwise, we'll print out a print message. And we'll say connection accepted. Okay, so now if I run this, what happens? Well, it tells me server socket has been created and it's waiting for a connection. The program is still running, right? I've got the little red button sitting out there. It's trying to, you know, be hospitable and wait for a connection to occur. So let's go ahead and do another netstat and look at TCP. And you can see down here, there's a TCP6 service running, listening on port 7777. Right, that's our Java program. And it's hanging out and it's just waiting for a connection to come in. Alright, so next really useful tool to know about in all of this is telnet. Telnet used to be how we made connections from one machine to another. The only problem with telnet is it doesn't encrypt. So your keystrokes go out to the network in plain text, and so if you type in a password, for example, it's there for everybody in the world to see. So we don't use this for secure communication. We don't use it for sending passwords and things like that. But it's a great tool for testing socket code, right? So I can telnet, we did this yesterday, you know, localhost port 25, I'm talking to my SMTP server. Well, if I'm on the Linux server, this will work. Actually, that should work. But I think it's set up so that it won't actually take connections from outside. But we did this yesterday on the Linux server itself, and we could talk to the SMTP server. Oh, nice, nice, yeah. This is classic. Thanks for posting this. This did used to work. Yeah, I've done this, but not too long ago, and it worked for me too. But you know, it's broken network Wednesday. All right, so I've still got this connection sitting out here on port 7777, waiting for incoming requests, and our program is still sitting out here running. So let's just go ahead and use telnet, and you know, we can get to our local host as 127.0.0.1. That's always us. We can also use the word localhost, and that's alias to this address. And I'm going to put in 7777. And as soon as I do that, we got a message here saying connection accepted. So our Java program responded to this telnet request, said connection accepted, and then the Java program exited, which shut down that socketed communication, which caused this telnet program to say connection closed by foreign host. That's my Java program. All right, let me see what this does. Mapski. Cool. Oh, but I made it exit. All right. So yeah, so telnet is still a thing. Don't be afraid of telnet. You know, people freak out and say, you know, it's a security risk and all that. Everything's a security risk, right? Having a front door on your house is a security risk, right? But you don't leave it open when you walk out, so, and you put a lock on it. So telnet's not a bad program, right? And we're going to write our own version of things like telnet, you know, in this class. But it's a useful tool for making a connection to a machine and a port. And you know, you can get to any machine that you want as long as there's something on that machine listening for network connections. So, you know, I can go to google.com port 8080 and it will try to talk to you know, the secure HTTP server on there, which it won't succeed at. But this will work. Right, so now I'm talking to the HTTP server on our Linux machine, and if I'm fluent in HTTP, I can send, you know, a message where I ask for a web page, and it will send it back to me. Yeah, listening to us is a security risk. But if I don't know the protocol, you know, it will say bad request and shut down the connection for me. So let's play with telnet a little further, and let's do something with this connection. So we're creating a server socket, we're accepting a connection, and then we're just exiting right now. So if we look at this accept method, you'll notice it actually returns a socket. So this picture is not entirely accurate. You make a connection from a client to a server at a particular port. For us, this is 7777. And the server code accepts that connection and creates a new port with some basically random number. And the socket that's connected to this port, that's the return value from the call to accept. And then that's the conduit over which communication happens with the client. And this port 7777 is really just used to initiate a connection. So now I'm talking to the server over this port, but another client, client 2, can go to that port and say, hey, I'd like a connection too, and it'll create a new socket, and communication starts happening here. And now a third client can come in and talk to that port and get its own socket and then start communicating. And each time that this communication sets up, right, there's a socket made on the client side that's connected to the socket on the server side. Oh, nice. Cool. All right, good stuff in the chat window. All right, so let's use the return value from accept to make a socket. So let's make a socket called sock, and let's import JavaNet socket. And then in here, instead of just calling the accept method, I'm going to say sock equals. Let's see, Windows has telnet. Oh, that's cool. And all this stuff, if you've got your own Linux system and you don't have something like telnet, sudo apt install telnet. Right, so apt is the package manager, install is a keyword which says install this, telnet's the thing you want to install. Sudo runs it as the super user, and if you don't have telnet, it'll go ahead and install it. It's telling me that I've already got the latest version. But that's how you can add things in Linux. All right, so we're going to accept the connection. We're going to get a socket. Let's go ahead and print out what that socket is. Like so. So let's run this, and we're waiting for a socketed connection. And let's telnet to port 7777. And you can see that it accepted a connection. The socket was 127.0.0.1, and the port was 36.802. That's the port number that was created by Telnet for carrying on this conversation. And if I run this again, and I make another Telnet connection, I'll get a different port number, 36.810. That's cool. All right. So what happens after we make this connection? Take a look at the socket class. And it's being created for us, right, by the accept method. So we're getting the socket back. But what we're interested in here is this thing called get input stream and eventually get output stream. So get input stream gives us an input stream that's associated with the socket. What's an input stream? Well, it's a thing that we can use to do, you know, various input and output. What's interesting to us is we can construct a scanner using an input stream. So we're going to keep using scanners and print writers, even though we're doing networked stuff. And so we're going to go like this. So we're going to make a scanner SC for reading from the socket. And let me go ahead and import that before I do the next thing. All right, and all we're going to do here is we're going to call the get input stream method of sock, which gives us an input stream. We're going to use that as a constructor to the argument to the scanner constructor. Take the result and save it in SC. And it should insist I throw that in the try catch block, but I've got a typo somewhere. What is a port physically? It's really just like a data structure somewhere. I don't know what the structure of that looks like, but you know, there's probably something like an array or maybe something fancier with one entry corresponding to each port, and it has various information about who's connecting to it and stuff like that. So it's really just memory and data in some sense, which is kind of cool. I deleted something somewhere when I thought I was pulling up documentation. So let me eyeball this again. Try this, catch this. Yeah, I lost the end of my catch statement. Okay. All right, so it wants this to go inside a try catch block because get input stream can fail. But once I do that, I think it's going to want the scanner construction to go inside a try catch block. So I'm just going to go ahead and manually try catch this statement. So I'll just print out an error message and exit. Otherwise, once we get down here, we've got, yeah, I really cannot type. We've got a scanner object ready to receive input from the socket. And so let's do our usual, well, SC has next line. and we'll just call next line to get the next line of input from the scanner, and we'll print that out. And when we're all done with this, we'll close our scanner object. And I guess we should close our socket server too. Except that's going to want to try catch. So I'm not going to bother with that. How come you didn't have to set SC and SS to null to initialize? So you never need to set these things to initialize, but if you do the following, if you do something like this, right, that will throw all kinds of errors because I'm declaring it inside this loop, this block. So I have to declare it outside. If I get rid though of this return statement, then it's going to complain. It's going to say this may not have been initialized. Because what might have happened, right, I declare a socket, I try to give it an initial value here, but I fail, so I come down to my catch block, I print a few things, and then I go on to here and I try to use the value of socket. So that return statement actually stops that error from happening. But the other way around that is, you know, to initialize this to null. That's just getting rid of this compiler error, but that's not really what you want, because if I run this and this fails, I'll throw a null exception when I try to print this out, or at least when I try to call the get input stream. So this is kind of a dance between, you know, what the compiler wants, what we want, and what the universe wants. So it's good stuff. All right, so we've got a rockin' program here right now. So the server socket is created, it's waiting for a connection. Let's go ahead and run our telnet session. Session has been accepted from port 36890. Okay, before we do anything else, let's come in here and let's do a netstat. And so we've still got this server socket sitting on port 7777, and it's in the state of listen. But now we have an established connection with a connection between port quadruple 7 and port 36890. This is the thing that's going on between my telnet session and my Java program. And it's established, so you know it's out there and it's running. And if I terminate this Java program, and then I run this, you see that connection is now in this time wait state. So it's a broken connection, and my telnet session exited. It said connection closed by foreign host, but this thing is kind of winding down, and eventually it'll disappear, but it can take it a minute or two. And if I try to do a telnet before I run my Eclipse program, right, it says connection refused, because there's nothing out there listening on that port. So if I run this, it's currently running, and I make my telnet connection, now I've got my connection established. And now if I do my netstat, here's the new connection that's been established. And it's using a new socket 36898. That's this one right here. And you can also see there's a parallel connection up here. Right, this is the connection from a local address of 36898, that's telnet, to the server. This is the connection from the server back to telnet. So netstat's a useful tool. You don't want to get bogged down in it, but it's handy to get an idea of what's going on. Meanwhile, we have a telnet session sitting over here. Now telnet, basically, when you make a telnet connection to a machine and a port, anything you type gets sent to that port, and anything received from that port gets displayed here. So if I say something like hello planet Earth and I hit enter, my has next line comes back true. I call next line, it picks up that line. So now I'm communicating with my Java code through a totally different program in a totally different window, just running telnet. And if I close out my telnet session, so telnet, control right bracket gets you out of telnet. I think it's left bracket. I've never written it before. Yeah, that's right. So control right bracket gets you out of telnet. That's worth noting. To gfet out. So if I control right bracket and I say quit, that shuts down the connection from the client end, and you can see my server program exited. Because the sc.hasNext line failed, and so it went ahead and shut down. So make a telnet connection, type some stuff, and then control right bracket and quit. And there it says connection closed. Now in this case, once the connection is closed, the whole program exits because I just fall off the end of my main method. But in fact, usually what you would do is you would put this whole thing in a forever loop, and when the connection closes, it would go back to listening for another connection. And so I could make a telnet connection, exit, make another connection, exit, and so on and so forth. Forever do a thing, close. There are forever statements in some languages, aren't there? There seriously should be. Yeah, yeah. We should make a really forever that like automatically blocks interrupts and ignores breaks and all that kind of stuff. Like really forever. All right, so we're running our server program over here. So I'll bring up my phone and bring up Terminus, which is just a telnet client basically. So I set this up in the morning class. So this is just a connection to 192.168.0.101. That's my laptop's address. And I'm going to port 7777. And I'm using the telnet protocol, which means basically no protocol. I'm not putting in a username or anything else, so I'll go ahead and do that. And we're still running our server over here, so I'm just going to click on my laptop icon, and there we go. It says connection accepted. So I'm talking to my Java program in Eclipse from my phone. And so I can say something like, you know, hello, typo, o'clock. And, you know, this is not an easy way. But, you know, I'll type in a message, hit enter, and there you go. So you know, this is networking, and I can come out of here, and let's say go ahead and close this connection. And when I close this, then it says connection closed. Now there's extra stuff coming in here, right? There's non-printable characters coming in, and I think that's because of some of the coding that program is doing. But you know, that's the basic setup. Let me do this one more time. So let me go ahead and run this. And let me bring this up again and make our telnet connection. So there we go. So if we come back in here and we do our netstat, so there's there's our connection, and it's connected to 192.168.0.214. That's the IP address of my phone. And so there's the connection from the Java program to my phone, and somewhere up here is the connection from my phone to the Java program. Somewhere up there. And then we can close that out. And there we go. Let's see. Control the machine to the point where pressing the power button does nothing. Yeah, that would be cool. But will it shut down if the sun supernovas? That's the question. Can you like teach it to like cool the sun and expand the black hole to really make it self-preserving? You got like 4 weeks left for your SLP. Bet you could make it good. Yeah, make it powered by the supernova. It just makes it stronger. Yeah, 3 weeks for the SLP. I think you could do it. So that's our basic, half of our basic setup, right? So server socket and the socket. That sets up the server side. The client side is really just a subset of that. On the client side, we simply create a socket using the socket constructor, and then we connect it to a server, an address and a port, and then we've got our two-way communication. And just like we said get input stream, we can also say get output stream and use that to construct a print writer. And then when we print into that print writer, anything reading from the socket on the other side will read whatever we printed. And anything that's printed in the remote side we'll be able to read when we call scanner has next line and next line. How is it spelled? Termius. But it's basically just a client program. So they're usually listed as like SSH clients, but usually you can, just like PuTTY, you can say what protocol do you want to use, and so on. So that's a reasonable one. But you know, we could also have used PuTTY. I have no idea where my, oh, there it is. Oh, that's not what I wanted to do. Alright, so here's our program. Let's go ahead and run it again. And our PuTTY client. So we can go to 127.0.0.1. We can choose basically a raw connection or a telnet, and let's put in the port number, quadruple 7. Go ahead and open that. There's our connection, and whatever we type in here comes out there. So there's a number of clients available. Termius is just one that I happen to find. All right, so Open Lab tomorrow. We'll finish up PA4. If you're having any final issues, come by, and we'll nail those down. And then Friday we'll talk about PA5, your last programming assignment for Clark. So we'll talk about PA5, which is going to be adding a network layer on top of your dots game. And we will play around with the client side from Java, see how to get that two-way connection going. And then we'll start talking about some of the aspects of how we use that for PA5. How do we share moves from one machine to another when you click, and so on and so forth. And we'll continue developing some client-server code next week, working our way up to a two-way communication, and that's going to take us into threading and looking at running multiple threads that do things simultaneously. And then we'll branch off and we'll just talk about threading for a while. Then we'll loop back and finish up networking, looking at URLs and things like that. So so good stuff in the next couple of weeks. All right, have a good afternoon. I will see you tomorrow.